We have to talk about the volume of prisms and cylinders. Thanks, sir. What are the formulas for prisms and cylinders? We need to learn and apply the formula for the volume of a prism. Learn and apply the formula for the volume of a cylinder. Volume and Cavallari's principle are our topics.
Pythagorean.
Alright, y'all write this down. Here's what you need to write down. The volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will exactly fill the interior. That probably means nothing, but write that definition down. Alright, we'll talk later about Cavallari's principle. If you want to know what it is, I'll tell you right now. Cavallari's principle says if two three-dimensional figures have the same height and have the same cross-sectional area at every level, then they have the same volume. We're going to look at that again in another example, but for right now, if you're desperate to know what it means, that's what it means. Sorry, Philip. Alright, next up, check it out. You want to write this down. By the way, your formula sheets have this for you. Okay? If you want to look on the right side, it says volume. We're talking about the volume of a prism. Formula for the volume of a prism. Okay?
Where is the prism?
On the right side of the formula sheet.
I don't see it.
It
Doesn't have to be pyramid, cone, sphere.
Where's the volume of a prism?
All
Maybe prism's not on there because it's the easy one. Okay? My bad. Guys, the volume of a prism.
Oh, it's base times width times height.
Length times width times height. Okay?
Oh,
Real
what's
simple.
that base?
Length times width times height, or if you want to think of it times big base times height, or if there was a cube on there, the volume of a cube. No.
Huh? Isn't the last thing was 2 hours?
They really rip you guys off.
Third.
Right? The volume of a cube is simply what? A square.
A long square.
When you take a height to a square. I tell you what. Hold on.
Angle.
Y'all write down these formulas. Not in this class. Alright? Here's how simple it can be. If you wanted to find the volume of this prism, what's the width?
3.
Sure. What's the length?
3. No, 5. No,
13. What's the height?
5.
Multiply them together. 13 times 3 times 5.
And
Length times width times height?
195.
195 cubic centimeters. Notice that my units of measurement are now cubic, right? Y'all hear me? This is really key. Guys, if it was 2 dimensions, what would that number be? A 2. But how many times do you multiply? You multiplied 3 dimensions together, right? You multiplied a length, a width, and a height, okay? And since you multiplied 3 dimensions, you're dealing with cubic measurements. You alright? You want this one? Okay. The volume of, I'll come back to it. The volume of a triangular prism with a height of 9 yards, whose base is a right triangle with legs of 7 yards and 5 yards. Anybody know how to calculate the area of a triangle?
Base. Oh, you got the
Mr.
bottom.
McCroskey,
Oh, God.
how do you calculate the area of a right triangle?
Right triangle? And then on here. Area equals 1/2.
Oh, yeah, it said that.
Radius squared.
Yeah.
The pi radius squared.
Yes. Pi radius squared is exactly how you calculate the area of a triangle.
Yeah.
No!
Oh, triangle. Oh,
No, it's the worst freaking answer I've heard all year. Because you're not paying attention, McCroskey. And if you keep not paying attention, I'm going to move you from the back of the class to the front of the class where you will pay attention. Understood. Good. Alright,
A equals the length of base times height.
guys,
So is it F?
all that's happened here is this. You got a right triangle. It says the legs are 7 and 5. Okay? To calculate the area of a right triangle, you take 1/2 base times height. So take 1/2 of 7 times 5. You got me? This is AKA, that's the big B. The big B, when you see capital B on your formula sheets, that means the area of the base. Okay, you got me? The capital B on your formula sheets means area of the base. So, Bradley, what is 7 times 5?
35. Dude, are you serious? Are you serious? Just that much.
Get him out of this
Wait,
place.
when did we 35?
35. Alright, and Bradley, to calculate the volume, what I'll do is this. I'll take big base times height, okay? So I take 7 times 5, which is 35. I take half of 35. I'll just help you out. 17.5. Okay?
I wouldn't know.
17.5. What is the height here, Bradley?
I think it's 7.
My gosh. The height is 9. So, to make sure you understand this, put 17.5 times 9. You better get this right.
You can't use a calculator.
I'm sorry. Yes, you please use a calculator.
157. Yeah, 157.5. That's crazy.
Bradley, is this going to be a 2 or a 3 right here?
What? Oh, it'd be a 2.
Bradley, you have now got yourself a new seat. You're going to sit right here behind Mr. Harris. Go ahead and move your stuff. I don't care.
Can you sit here? Please.
Oh, yeah, for today you can sit behind Booth. That's where you're sitting now. All right.
No, put him right here in front of me.
Put him right here.
Actually, can sit
A
beside
swimming pool is a rectangular prism. Estimate the volume of water in the pool in gallons when it is completely full. Hint, 1 gallon is approximately 0.134 cubic feet. The density of water is about 8.33 pounds per gallon. Estimate the weight of the water in pounds.
What?
Yeah, we do problems like this, and they're converting units of measurement, and it's like,
Dude, you got me.
Wait, why is there 1 gallon and then
all right, check it out.
He's always
30 plus feet?
Here we go. Find the volume of the swimming pool in cubic feet. Guys, how do we calculate the volume of a rectangular prism? Right there.
Okay, I was making sure because everybody was.
Hurry up.
Go here.
Open up a notebook and take notes.
Yes, sir.
To calculate the volume of a rectangular prism, we take length times width times height. This has a length. Oh, they messed up bad. They done messed up now. 25 times 15 times 19 is definitely not. So 25 times 15 times 9. Guys, this don't mess up here. This should be a 9. 33.75. Alright, check it out. Step 2. Here's what you gotta do. You gotta convert from, you wanna eventually convert from feet to gallons. Okay, so we're gonna use our conversion scale. Y'all heard of this before, right?
No. Yeah.
Yes, you have. 1 gallon is approximately 0.134 feet, which means that if I have 3,375 cubic feet, and I multiply that times my conversion, I end up with approximately 25,186.57 gallons. If you want to know how to do that. Who wants to know how to do that?
How you multiply?
Perfect. Yeah. Just do like this. Take your calculator out. Okay. Type in 3375 times, and then make a fraction. 1 over 0.134 hit equal, and you should get approximately 25,186.57. Okay, y'all with me?
Is there one of these things on here? Can you do that one? Get close to the front. Sit right there.
Alright.
Oh, that's what we did last year.
From there, check it out. From there, we're going to use another conversion factor to figure out how much this weighs. Okay? So, you guys type this into your calculator. I want you to practice typing this into your calculator. 25,186.57 times 8.33 over 1.
8.33.
20,000. 200.
Or too fast.
209,000.
Mr. Oz is kind of.
Oh, yeah.
Look at that.
209,000.
You see this? When I put this in, it does that.
209,827.
I'm in the millions, man.
Alright, 209,804. What you should have been getting, okay?
Okay.
Follow your conversion skills, you'll be alright. Yay! One of my faves. Cavallari's principle. Cavallari's principle is simply this, okay? It relates more to cylinders than it probably does anything else. How many of you have ever heard of what's called the Leaning Tower of Pisa? How many of you have ever seen a Goofy movie? You kids haven't seen a Goofy movie?
Yeah.
Some of your lives are forever. No, the Goofy movie. So the guy has the Leaning Tower of Pisa. Okay, never mind. Yep.
Wait.
We got on that. So, would you believe that the Leaning Tower of Pisa and the tower next to it that has the same area and the same height have the same volume? Yeah. And they're not going to look like they have the same volume, okay? But they do. All right? They do. Here's why. With cylinders, all radii are created equal. So as long as, check it out, y'all, as long as the circular base of the two figures has the same radius, that means that it will have the same area, because we use pi times radius squared to calculate the area. That's how we find the big base, right? Okay, big B equals, see this? Big B is the same thing as pi r squared when it comes to the volume of a cylinder. Okay? So as long as you've got figures with the same radius and the same height, they have to have the same volume. And we can try and trick you. Here's some of the tricks we play. We say stuff like this. We say, yeah, so I got one cylinder, looks like this, and then I got another cylinder, and it looks like this. Okay? And what I do is I say the radius are equal, and the height is also equal. And look how they calculate the height. They've drawn this for you. The height is the same in both of them. True or false? They have the same volume.
True.
It's true. Okay? It's true. All it means is that it's pushed over, alright? But through what we call Cavallari's principle, if you see a question like this, and you're given that they have the same radius and the same height, you know automatically they have the same volume. So,
I would think it'd be false because that one takes up more space.
what the trick that they're trying to play? The thing to look for, radius and height. Okay? You would think it would be false because it takes up more space. Okay? But you would be wrong. It doesn't. Alright? It doesn't. Geometrically, it doesn't. If they have the same radius and the same height, then we're good. Any questions on that?
So could you like use either one of those formulas that down at the bottom?
Down here? Yeah, you can use either one of them. But understand, to get big base, you're going to have to calculate pi r squared. You might as well use this one. Okay?
Yeah, I was thinking.
Yeah, I
I
was thinking you cracked yourself.
Alright. Right here. Find the volume of the cylinder.
Is that more?
Yeah.
Wait, what? I thought it was just a desk I was sitting on, like his
Here.
marker board. That's awful.
Hurting.
No, please don't. Ah.
Wait, why is it, what's it smell like?
Spill it.
God.
I can smell it.
It's gonna be my torture marker.
Oh, God.
That's it.
Gordon didn't smell it.
Yeah,
Gordon has to
Gordon
smell
didn't
it.
smell it.
Yeah,
Gordon's got a
ass, straight ass.
It's my torture marker.
Yeah.
Next time somebody doesn't pay attention, I'm just gonna put this on the back.
Don't
Alright.
smell it, you know.
Find the volume of the cylinder, give your answer in terms of pi, round to the nearest 10. Time out. Whoa, whoa, whoa.
Oh.
14 is the height. Why are they using 9?
Oh.
Because it's
Miss Craig.
That's the marker.
Miss Craig, it says 18 in the diagram.
That's not the diameters.
Oh, that's the diameter. So what do you have to do? Guys, quit talking about the marker. Start listening to Hannah. What do you have to do to the diameter to find the radius? Split it in half. Divide by 2. 18 divided by 2 is 9.
I was thinking
Okay.
that, but he had 14.
Woo! Find the volume of a cylinder with a base area of 121 pi cubic centimeters. Oh, no, square centimeters, and a height equal to twice the radius. Give your answer in terms of pi, round to the nearest 10. Oh, dear. Find the volume of a cylinder with a base area of 121 pi centimeters. A height equal to twice the radius. Who has a clue where to start this from?
Radius.
Yes, ma'am. How do you do it?
You draw it.
No, let's draw a picture.
Close.
Draw a picture.
Area is pi times radius squared, correct? Okay. Volume is big base times height, right? The only thing I've got is I've got A. I know that A equals 121 square centimeters, okay? So Hannah, before I square root 121, I want to get rid of pi. You with me? Okay? So, now that I've done that, how do I get r by itself? Square root. Now we're ready to square root it all. I square root it. What is the square root of 121? 11, right? 11 is equal to the radius. Now there's an interesting thing, okay? I've got that the radius is 11. Is that my answer? Give your answer in terms of pi. Find the volume. I'd say no. What am I trying to find? The volume. What did the radius help me get in this problem? Read the problem, guys. The what? The height. The height is what? So what is 2 times 11? So what is the height here? 22. Which means that, check it out, we knew that the big B was 121 square centimeters. We multiply that times 22, and you get your volume. Oh, I'm sorry, 121 pi. Good call. Good call, balls. Okay? She can correct me. That's fine. Alright. No. Here we go. Exactly what we did. We found our radius, multiplied it to find our height. What we get here? 266. Yeah, 2,662 pi cubic centimeters. Yep. Second, or shift, and then that. Alright, right here. The radius and height of a cylinder are multiplied by 2/3. Describe the effect on the volume. Please, please, please pay attention right here, okay? Here's what you need to do. You need to find the original volume. The original volume, all you gotta do is come over here. Pi times 24 squared times 33. You get approximately 19,008 pi. And then do what the question says. Multiply the radius and the height by 2/3. What's 2/3 of 24? 16. What's 2/3 of 33? 22. And then calculate the volume using those dimensions. And then look, what happened to the volume? It shrank. How much did it shrink by? Over half. Do this. Take 19,008 pi and divide it by 5632
Divide it.
pi. Divide it. Okay?
What's the combo then?
Divide it.
It's like, it's 3.3.
Yeah. It's 3.375, and if you look at the fraction form, it's almost 27/9, which is exactly 3, right? So it shrank by almost exactly a third, okay? No, I said that wrong. 2/3. Cool. We have another thing, one last thing I want to talk about today. They're called composite figures. Okay? They're really, really easy. Here's why. So find the volume, it says find the volume of the composite figure. Okay, Mr. Hobbs, how do I do that? Simple. How many different dimensional figures do you see up there?
2.
There's 2 different 3D figures, right? You've got a rectangular prism, and then you have a pyramid stacked, or a triangular prism stacked on top of it, right? Okay, guys, it's as simple as this. Find the volume of the rectangular prism, find the volume of the triangular prism, and add those volumes together. If I may. Thank you. If I wanted to know what the volume of the composite figure was, right? You'll see what you do here. You take the volume of one figure, you take the volume of the other figure, just add them together. Okay? So when you see composite figure, think about that word composite. You know what composite means? What?
Like a bad.
A list. It means a whole collection. Think of it like a collection, okay? You're going to be adding together all of the particular volumes in the particular figure, all right?
Like those the closet shafts or whatever.
Sure.
Yeah, we'll go with that.
Oh, you're
Probably.
like for golf, the composite shafts.
I have. I don't know what that means
Right.
from a physics standpoint. Any questions? Anybody need any slides?
So